Alright, we will start with the problems based on elasticity. Okay, so problem number 1. Determine the elongation of a steel bar 1 millimeter long and 1.5 centimeter square cross sectional area when subjected to a pull of 1.5 into 10 to the power 4 Newton. Okay, they have already given a value, that is y is equal to 2 into 10 to the 11 Newton per meter square. This is the given Young's modulus. So we know that the y equation is f by a whole divided by, this is delta L by L. Okay, so now we can see that in this particular case, force is given, area is given, L total length is given, and y is also given. So which means we can directly find out the delta L. So before that, let's try to simplify this. This becomes FL, this is FL divided by A into delta L, that is y. So if you want to calculate the delta L, that is change in the length, this should be equal to FL divided by A into y. So let us substitute. So this force is given as 1.5 into 10 to the power 4 SI unit into L is, right, it's, I can write 1 millimeter, so 1 into 10 to the minus 3 whole divided by 1.5 into, its centimeter square. So if you want to convert this into meter square, I have to write centi is 10 to the minus 2, minus 2 square becomes minus 4. Okay, into 2 into 10 to the 11. Okay, so let's solve this now. When we substitute this in the calculator, 1.5 will cancel, 1 by 2 is 0.5, 4 and minus 4, 8 minus 11. So this becomes 0.5 into 10 to the minus 3. Okay, so 0.5 into 10 to the minus 3 is nothing but 0.5 millimeters. That is the amount of change in the length whenever the particular force acts on the given body. All right, that's the first question. Then let's go to the question number 2. If the bulk modulus of, say, water, okay, it is 2.3 into 10 to the 9 Newton per meter square. All right. Part A of the question, find its compressibility, and part B of the question, how much pressure is needed to compress a sample water by 1%. All right, so let us calculate. We need to calculate the B value. B is given. So B is equal to, this is 2.3 into 10 to the power 9 Newton per meter square. Okay, so this has to be normally represented in atmospheric pressure. That's what that's when we are able to represent the given data set using the following notation. Okay, so that means this is equal to, you have to convert this 2.3 into 10 to the power 9 whole divided by, this is 1.01 into 10 to the 5. That's a standard atmospheric pressure. So that this becomes, B is equal to 2.27 into 10 to the power 4. This is in atmosphere. So ATM, so many atmospheric pressure. We are converting the B. Now the question says that what is the compressibility? So I'm answering part of the question. So that is the CO. Compressibility is 1 by B. So just represent this 1 divided by 2.27 into 10 to the power 4. So this becomes equals to 4.4 into 10 to the minus 5. It's per atmosphere. Okay, so that's the way of writing this. Then the part B of the question, it says that we want to have the given data is, you have to reduce it by 1%. So that means I have to write the delta V change in the volume per given volume is equal to minus of 0.1%. This is the question, right? So minus of 0.1% is nothing but minus of 0.001. So what is the change in the pressure required? So that is, I can call it as delta P. Delta P is change in the pressure is B times delta V by V. So this is the equation. It's reducing, so minus. So that is, B is nothing but 2.27 into 10 to the power 4 into the delta V by V is negative of 0.001. So you can see that the change in pressure required here is 22.7 atms. Okay, so that is the answer of this particular question. All right, then let's go to the next question. It is, a steel wire of 4 meters long is stretched by 2 millimeters. Okay, the cross sectional area, okay, is 2 millimeters square. All right, if and the y is given, y is equal to 2 into 10 to the 11, this is Newton meter square. Right, so the question is find part A of the question is energy density, and part B is elastic potential of wire. Okay, so we can note what is given. Length is given, this is 4 meters. Then see delta L is given, this is equal to 2 into 10 to the minus 3 meters, 2 millimeters. And you can see that the area is given, that is A is 2 into 2 millimeters square, right? So milli is 10 to the minus 3, its a square is minus 6. Okay, minus 3 into 2 is minus 6 meters square. Then the y is anyway, it's given. So you can calculate the energy density, right? That is equal to half times the stress into the strain. Okay, so stress is denoted by, since the it is unity, we can directly write y times strain square, because I don't know what is the stress, but I can definitely calculate the strain here. So this means I can write it as half y into the strain square. Why? Because stress by strain is a constant. So stress by strain is a constant, that is y. So stress is not known, I can use y into strain to do that. There is already a strain, so strain into strain becomes strain square. Instead of stress, I write y. Okay, so let's write this. Let's substitute this. This is equal to, there is a half into y is given, you can see that this is 2 into 10 to the 11 into strain square. Strain is delta L by N, so delta L is how much? That is 2 into 10 to the minus 3 divided by L is how much? That is 4. So take the square of this. Okay, now we need to substitute this in the calculator to get the answer. Okay, let's do that. So half into 2 into 10 to the 11 into, this is 2 into 10 to the minus 3 by 4 the whole square. Okay, so now the answer is 0.25 into 10 to the power 5, right? In order to convert this into a standard value, we can convert this as 2.5 into 10 to the power 4. This is energy density, so joules per meter cube is the unit. Okay, and part B of the question is nothing but, this is the elastic potential, that is nothing but energy density multiply that with the volume. So this is nothing but energy density. Just now we calculated this is 2.4, oh, sorry, 2.5. I think just now we calculated that 2.5 into 10 to the 4 energy density into volume is nothing but area is known, area into length, correct? So area is 2 into 10 to the minus 6. This is area into length is 4. This is what is the volume. Okay, let us substitute these values in the calculator. So that is 2.5 into 10 to the 4 into 2 10 to the minus 6 into 4. So this comes to be 0.2, since it is energy, right? Potential in joules. So zero point 0.2 joules is the required answer. All right, let's proceed further. We have a rubber cord has area 1 millimeter square and the total unstretched so and total un, total unstretched length of 10 centimeter. This is the total length. Now let us say that this is stretched. It is stretched to 12 centimeters. Right? It is stretched to 12 centimeter and released to project a 5 grams mass. Okay, calculate the velocity of projection. So take y is equal to 5 into 10 to the 8 Newton per meter square. Now we first need to calculate what is called as a force constant of that particular object. So we'll write force constant, say k. It's nothing but y into area by L. So y is 5 into 10 to the 8 into the area is 1 into 10 to the minus 6. That's the area given in millimeter square converted into meter square divided by L. 10 centimeter is 0.1 meter. So this k comes to be 5 by 0.1, 8 minus 6. So this is 3. So this comes to be 5 into 10 to the 3. This is Newton per meter. Okay, once you have this value, now I can actually calculate the energy, right? So you see that the elastic potential of this cord, right? So the cord potential is should be equal to the kinetic energy of whatever you are trying to launch using that. So because potential energy gets converted into the kinetic energy. So we equate elastic potential energy is equal to the kinetic energy. So what is elastic potential energy? That is half into K times this delta L squared should be equal to half mv squared. So half gets cancelled. My intention is to calculate v. So v becomes equal to, I should take a square root. So k by m into root L. So this is directly I can write root of k by m into the delta L. So I just have to substitute this to get the answer. So k is 5 into 10 to the 3. M is 5 grams. So 5 into 10 to the minus 3. This whole under root. Multiply this with the delta L. Delta L is nothing but it's 12 minus 10, right, into centimeters. So this is 10 to the power minus 2. Right? Okay, let's substitute this value in the calculator. So 5 cancels. This is 10 to the power 6. 12 minus 2 is 12 minus 10 is 2. 2 into 10 to the minus 2. 10 to the 6 is there. So 10 to the 3. So this becomes 10. So this becomes 20 meters per second is the required answer. Alright, let's proceed further. Alright, the next question. Alright, this is the next question. If the elastic limit of copper is 1.5 into 10 to the power 8 Newton per meter square, calculate the minimum diameter. Minimum diameter of copper wire that can uh, that can have a 10 kg load. So this is without exceeding the elastic limit. So what should be the diameter of the copper wire so that you can have 10 kg without exceeding the limit, right? So we know that the force that you apply divided by the minimum amount of area, that is A minimum, is nothing but the sigma. Okay, so that's sigma is itself is this elastic limit. Okay, now under this condition I need to substitute for area first. So area in terms of diameter, let's write. So this implies the force divided by, so if you want to write an area in terms area of a circle in terms of diameter, so that is pi into, this is d square. So since this is minimum, it should be d minimum. Okay, d minimum square by 4, pi d square by 4, either it is pi r square or pi d square by 4. This should be equal to sigma m. Right, now let's calculate the d min. Therefore the d min is equal to 4 times f divided by pi into sigma m under root, because d had a square. Now I need to write a square root. So let us substitute. This is 4 into force is given, so it's a 10 kg. So converting 10 kg is mass into the weight, that is 10 into 9.8. 9.8 is the acceleration due to gravity. That will convert the mass into force or the weight. Okay, divided by pi, which is 3.14 into sigma. It's given 1.5 into 10 to the power 8 whole under the square root. Okay, let us substitute this in the calculator. So this comes to be 9.1 into 10 to the minus 4 meters. So converting this into a standard unit, I can actually make it as a millimeter. Minus 4 becomes, if I write it to the left, it becomes millimeter. 10 to the minus 3, 0.91 millimeters is the required answer. Okay, then let's go to the next question. Find the greatest length of steel wire. Of steel wire that can hang vertically, without breaking. Right, so they have given the breaking stress, right, is 8 into 10 to the 8 Newton per meter square. Density is equal to 8 into 10 to the 3 kilogram per meter cube, and G is equal to 10 meter per second square. So the maximum stress inside a object is obtained by having a weight by area. Okay, so this is, I can write maximum stress, that is actually denoted by sigma m. This should be equal to the weight divided by the area. So I can write W by A. Okay, but you see here, uh, the weight is actually the force. I need to convert this into force, right? So I have to write this is equal to, so sigma m is equal to sigma m is equal to, I can write, how do I convert weight? Weight is mass into the gravity, m into g, but m is not given. There is a density is given, so density into volume. I can do that. Okay, so this means I can write the area into length into this density given times g divided by area itself. Okay, so area, I think I wrote a small letter earlier, so let me make it small here. Okay, so this is a, so this and this will cancel. So how do you calculate L now? So L is equal to, this is sigma m divided by, we are left with only rho and g, so this is rho into g. So let us substitute the value. Therefore L is equal to sigma m is 8 into 10 to the 8 divided by rho is 8 into 10 to the 3 into g is 10. So you can see that the length is nothing but 10 to the power 4 meters. All right, that's the answer. Then let's go to the next question. This is bulk modulus of water is 2.3 into 10 to the 9 Newton per meter square. Taking the average density of water as rho is equal to 10 to the 3 kilograms per meter cube. Okay, find the increase in the density at a depth of 1 kilometer. Okay, consider g as 10. Okay, now which equation we are going to use? It's a straightforward question. So change in that. So change in pressure is delta P is equal to the rho into G into H. Okay, so now this means the delta P is equal to G into H can actually substitute it as, this is, what is GH? GH is nothing but once again delta P by the bulk B. But delta P actually I can write it as rho into, what is delta P? Delta P is once again rho into G into H, right? Divided by B. So what is the delta P? I can calculate this as rho square GH divided by B. So I just have to substitute all the values. Rho is given as 10 cube into G is 10, H is 10 to the 3. Okay, so rho square, sorry, there is a rho square, so this has to be squared, my mistake. So 10 to the 3 squared into 10 into 10 cube whole divided by B is given, which is 2.3 into 10 to the 9. So this means delta P change in pressure becomes 4.33. Yeah, I get 4.33 into, this is 10 to the power, okay, 433 into 10. So this has no 10 to the power. Okay, so I'm not getting any powers. So let me keep that as it is. 4.33 units kilograms per meter cube. Okay, this is nothing but the change in the density. So that's what is asked. How much the density will change at a specific distance. All right, moving further, the next question is this one. The pressure of a medium is changed from, this is 1.01 into 10 to the 5 pascals, to the new value is 1.165 into 10 to the 5 pascals, right? And the change in volume is actually the 10%, right? Then calculate the bulk modulus, right? So what is this bulk modulus? B is calculated as change in the pressure divided by, this is delta V by B, standard equation, we already know this. So how much is the change in this? It is 1.165 minus 1.05 into 10 to the 5, that's the numerator, whole divided by, see the change is 10%, so 10 by 100 I can write. Okay, so let us calculate this now. 1.01, yes, we'll correct that. So this becomes equal to 1.01, yes. So this comes to be 4 5, I think 1.55 into 10 to the power 5. Okay, so this is the required answer. All right, let's move ahead. Then the next question is, okay, this is a question. A sphere of radius 0.1 meter and mass 8 kilograms, right, is attached to a steel wire of length say 5 meters and the diameter 10 to the minus 3 meters. Okay, length 5 meter and okay, then this wire is suspended from a ceiling of 5.22 meters high. All right, now we need to calculate the extension of wire and the tension in this wire, taking y as 1.994 into 10 to the power 11 Newton per meter square. Okay, so the first part is calculating the extension. So let's write the extension is denoted by delta L. So delta L is what I need to calculate. So the equation is that they have told that the total height is 5.2, which means the length of the wire plus the what do you call this delta L plus 2 times the R value. This should be equals to, right, 5.22. That's the maximum height that is possible, right? So this means the delta L is equal to 5.22 minus the length of the wire minus 2 times the R value. Okay, that's the radius of the whole sphere. So totally it can, right, it can be up to this much. So delta L is equal to 5.22 minus length is 5 minus 2 times radius of the sphere is given at the beginning, that is 0.1. So you can see that the delta L is equal to 0.02 meters. This is the maximum what you call extension that is possible under this condition. That's the first part of the question. Then we need to calculate the tension in the string. So what is the tension in the string? I can calculate using the Young's modulus. That is tension. It is the internal stress per area whole divided by the delta L by N. So this means if you want to calculate the tension in a string, it should be, I think A goes to other side, Y into A, delta L also goes to the other side, whole divided by N. But T is equal to Y is, okay, I don't know the area, I have to use the pi r square, that's all. So this is 1.994 into 10 to the power 11, this is given, into I need to write area, so pi into radius square. So zero point 0.5 into 10 to the minus 3, because diameter is given, I'm making half of that, into square, into delta L, just calculated 0.02, whole divided by the total length, that is equal to 5. Alright, now let's calculate this value. This implies the tension is equal to 1.994 into 10 to the 11 pi 0.5 minus 3 whole square into 0.02 by 5. So this tension is going to be 626.43 newtons. So 626.43 newtons is the final answer.